Bonjour à tous et bienvenue
So,
à ce séminaire sur le
good
castor
afternoon. Welcome
et
to
le
this
travail de changement
seminar
climatique.
entitled
Donc,
Beavers, Allied
ce
Species
séminaire
for
avec
the
Clément
Environment
George.
within a context of climate change.
Donc, bienvenue à tous.
So, welcome to
Juste
all
pour
of you.
commencer, quelques
Just to
mots sur
start, a couple of
l'environnement
words about
extraterritorial.
H2O Lyon and
Lyon est une école universitaire de
this. We
recherche
are
qui a
a
été fondée
research
il y a
university
5 ans
center
et qui
founded
est
5 years ago,
multimédia et qui regroupe
funded by the
différents laboratoires de
state,
recherche
and
à Lyon et
we
Saint-Étienne qui travaillent
include
sur
all
l'ONOS
research labs in Lyon and
et la
Saint-Étienne
gestion
region
des
working
hydrocycles.
on
Et
freshwater and
l'objectif, c'est de
hydrosystem
faire aussi des
management,
formations de
as well
chercheurs et d'étudiants
as
gratuites pour tous,
training
avec
in
l'idée de se
masters and
développer
PhDs.
l'interdisciplinarité
And we foster
l'international
interdisciplinarity,
et
international
voir
exchanges,
la
the link
recherche
between research and the
socio-économique et
socio-economic
également
world, and we ensure
formation et
link between
pratique. Donc
training
c'est dans ce
and
cadre-là qu'on
research.
organise
And within
régulièrement des
this
webinaires
network, we do
pour
regular
transmettre
webinars
des
in
connaissances
order to share knowledge,
scientifiques
scientific
et on
knowledge,
travaille donc avec
and
plusieurs
we work with
universités
Réseau
euh,
Rivière, and
sur lesquelles on peut
Antoine
intervenir.
will tell you a few
Merci
words about
Camille.
that.
Oui, effectivement, ça
Thank
fait
you.
quelques années qu'on travaille
We
avec
have been
Beaver
working
pour
for
créer
quite a
des
few years
ateliers
now to
autour des
do
riverscapes. Donc
webinars to
Réseau
work
Rivière,
on
c'est un ensemble
river
de réseaux régionaux
network managers. So we are a
français
network of several
travaillant autour des rivières,
French groups
c'est-à-dire
working
sur les
on the
problématiques de
topic of
pollution.
rivers. They're
Et là,
often
aujourd'hui, c'est un leader finalement
often
sur
public
la
authorities, and we do the link between those
et
local authorities,
des scientifiques, mais
the
aussi de mettre en
local
place.
agencies, and
Donc tout
scientists.
de suite, je vais te laisser Clarisse
With no
présenter
further ado, I'll allow
la mise en
Claire-Lise
produit.
to explain the mode of
Alors,
operation
est-ce que
today.
ça veut bien changer de slide? Donc, on va dire, ce séminaire sur les castors
This seminar on beavers includes 3
démarrer.
dates
Et juste quelques mots sur
and
comment on
a couple of
organise
words on
ce
how
séminaire.
we
Donc,
came
on
to
organise
this
donc 4
project. I know
webinaires
we organized webinars
sur les techniques type castor et les techniques
on
alternatives
the
de
beavers
restauration.
like
Dans ce
technique and alternative
cadre-là,
techniques for
avec
water.
l'appui d'un chercheur
And
américain, Clayton, on en est venu
we came
à
to the
cette question
conclusion that we
du rôle du
should pay
castor
attention to the
dans
role
la
of
restauration des
beavers
rivières
in the restoration
et
of rivers and
également la
streams.
déforestation
And
en Lyon
students
Saint-Étienne.
from the
Donc ça,
master in
c'était
Lyon
pour
worked on
le
this, and this is
premier
why they will attend
webinaire.
the meeting today.
Deuxième
They will be
date avec
facilitators. 2 dates
bibliography. Donc on va
today.
discuter
So
du
we will
castor comme
discuss
ingénieur
beavers as an
environnemental.
engineering species,
Et
with
puis
their
enfin,
impact on
troisième
restoration.
résumé
There
par
will be
rapport aux
introduction and
études qui ont été
summary of
faites
a
sur la
biographic report done
biodiversité en
by
Lyon
3
et présenté par
students,
nos collègues
bibliographic,
Clément George
Margaux Predhomme,
et
Arnaud Forêt, and Clément
Fintoni.
George, and they will facilitate the
Ensuite, il y aura
discussion.
une
Then
intervention par
we'll
Annegret
hear
Larsen
Annegret
sur le rôle
Larsen
des castors
on
sur
the
la structure
influence
des
of beavers on the
écosystèmes
structure and functioning
et
of river
on
corridors.
terminera par
And
Chris
we'll finish with
Jordan
Chris
qui a
Jordan
bien
from
voulu
the US, who was
anticiper
very kind enough to
peut-être
replace on the,
la
the
chaîne de
initially planned
fiabilité et
speaker.
nous
And
viendra parler
Chris will
aussi
talk
du rôle
about
du
the
castor
beaver ecosystem
et
services
aussi de
and
plus
how our
précisément
societies
du
benefit
castor.
from beaver riverscapes, what you call the riverscapes.
Juste quelques consignes. Donc ça, c'est la première date. Et il y aura une deuxième date. Donc c'est
There will be a
lundi
second
prochain à
date
14
next
heures.
Monday
On va
at
justement
2
discuter de la
o'clock.
gestion du
We'll
castor et
discuss
ses expériences au capital
we'll discuss
et
the
connaissances.
feedback of
Donc il y aura
experience
une intervention de Johan
sharing of
Bresson
experience. There
qui
will
va
be
revenir sur la
someone from
biodiversité, sur les
there will be Jan
aspects
Bresson from the French Office for
biodiversité
Biodiversity.
qui se
So
passent
what can we learn
dans
from
les rivières.
reintroduction
Il y
of
aura
beavers in
puis
France? Then we'll have Christy Stuff Ang in how to manage beavers in a
et
cultural
l'exemple des
landscape. The
États-Unis
example of, and then
sur une
Emily
participation de beavers
Fairfax from
pourquoi
will
ça
explain
c'est
to you how
pour
we can help beavers to return and
les
why. And
archéologies pour
this, of course, there
l'archéologie.
will be examples from different countries as
Donc
today,
pour que
as
le
of today.
webinaire se passe
So,
bien, il
as
est
we do today,
utile
so please
d'éteindre votre
first turn
caméra
off your
et votre
camera
son.
and your microphone if
À
you're
la
not
fin de la
talking.
présentation, il y
And
aura
at
une
the end of the
session de
presentation, there will be a
questions-réponses
Q&A
et je
session.
vous invite à
And we invite you
inscrire vos
to
questions dans le chat
download
pour poser
your
des
question
questions
into
pendant
the
l'intervention
in the
et
chat.
à la fin
And at the end, the questions will be asked to the speakers by the facilitators. That's for the short introduction. And again, give the floor to Margaux, Arnaud, and Clément, who will do the introduction on this topic.
Donc, bonjour à tous déjà.
Good afternoon. Thank you for being with us today. As we said, we're here today to talk about beavers, more specifically their role as an engineer species and the role and impact in the restoration of riverscapes. So let's start with a summary. I'll start with a summary of the bibliographic report that we wrote on this topic within the framework of our master. The two species of beavers, European and North American, fall in the definition of engineering species as defined by John and Al in 95. They build dams, they control the level of water, and they modify the environment they occupy in order to make them more favorable to their survival. And they also modify a lot of biotic and aquatic biotopes, and they control the structure and the dynamics of the ecosystems and the habitats where the beavers reside. For example, beavers will increase the total surface of wet land and water level. They increase the groundwater tables as well, the level. They also do scouring of the landscapes. They protect the scouring of landscape, and they create secondary channels or streams, within even the floodplain. And generally speaking, this lead to a complexification of the rivers with swamps, wetland, channels, and dams, and they reconnect with the floodplain and a better lateral connectivity, which is facilitated by the accumulation of water. At the same time, we do observe a sort of flood control, flood damping, and of course, and the zones which are occupied for the zone occupied by the beavers. They also store nutrients, phosphorus, carbon, nitrogen, which increase the primary production of the system which is impacted and reduces the level of such elements at the outlet, which is a purification process. Likewise, with a suspended solid with like fine sediments, which in fact will have an impact on turbidity. And at the ecological level, there is a high complexification of ecosystems used by beavers with a higher diversity of habitat and possibly species which are adapted to, maybe could be micro habitats, or it could be the entire landscape, a riverscape. A lot of those habitats would not exist without the beavers, and therefore they provide facilitate the survival of species and communities which were not there if the beavers were not present. They could be advent of benthic communities in a slow velocity, and they will be other adapted to higher velocity. They also be refuge, and the beavers have a selective food, supplied through the by trees, and therefore they change the landscape and they change the communities and the vegetal population. As you probably know, beavers population dropped in the last centuries, and they almost disappeared from many regions. And therefore, a large part of the ecosystems in zone today are, in fact, simplified and a poorer form of what they used to be because of the diminution of the population of beavers. Well, now, French rivers or European rivers are degraded because of the direct or indirect impacts, and the European Framework Directive is there to ensure the proper environmental condition of the rivers. So the beavers will actually contribute to a pre-perturbation restoration, and therefore it should be noted that beavers are not present on all rivers. The ones with low gradients are usually have a higher density of dam than the ones with high gradients. Likewise for the major rivers, which often are less dams, beaver dams. So we have to look at all the aspects, anthropic, hydrologic, and so on, because they have an impact on the possibility of restoration associated with them. So I will now leave the floor to Arnaud, because I talked enough.
Oups. Très bien. Alors, pour ma part,
Now,
je vais vous parler
let me
plus en
talk
détail
to
de
you
deux
in more
recherches
details about
scientifiques.
the situation of
Une
research.
grande majorité
The
d'Amérique
most of
du Nord.
the publications come from
Cependant,
North
nous avons
America.
failli
However, there
quelques
don't seem to
constats
be major
importants
differences in terms of impact between the two species, the canadensis and the fiber.
et les résultats
And
sont
the
relativement
results are comparable, at
identiques
least when
aux
it comes to
sédiments.
hydrology and sediments.
Ces résultats ont
The
été
results
validés par
were validated
d'études
thanks to the increase of studies on the European beavers since about 2010 in Europe. A pilot project for reintroduction and restoration of beaver population, especially in the UK, but throughout Europe, tend to demonstrate that there are beneficial effects of such restoration and reintroduction because, first beavers are back, and the utilization of beaver dam analogs in some, that is beaver dams made by man. These studies provide a better knowledge of the impact of these so-called low-tech restorations, which have, of course, a lesser impact on the environment, while making it possible to recreate a lateral connection between the river and the major bed, and also by fighting against incision of the river banks. A study from a University of Oxford came up to the conclusion, that is to say, with preliminary conclusion, with a preliminary consultation and planning, the reintroduction of beaver should provide significant advantages or benefits to the local economy and the communities, which could compensate for the potential negative impact. Now, the topic of beaver is more and more discussed in scientific literature and in all disciplines. And when it comes to its role as an agent for the restoration of aquatic environments, as you see on this graphic, it so happens that the number of communication is increasing since the early 2010. About 70% of the of publications come from the US, but more and more, thanks to our colleagues, European researchers, there are also publications. Despite an increase of knowledge, some doubts do remain, especially when it comes to the impact of the reintroduction of beavers on invasive woody species, and research would tend to look at this topic between the invasive species and non-invasive species, because beavers tend to prefer non-invasive species. A second text concerns the continuity for aquatic species and sediments, or the impact on floats. A lot of studies seem to be contradictory depending on the environment where the beaver populations are located, the locations, but also which factor will control the scope and the orientation of beaver dams on the landscape. Is it the flow hydrology, surface hydrology, whatever? So finally, last line would be the relationship with humans and the adaptation to this neighbor, which can use a lot of space you know,
Et
and how far is society and the stakeholders would be, how far would they be ready to leave space to the beavers, especially in Europe, and to talk about the economic impact in terms of cost, but also in terms of services provided. First assessment would say about a cost of 6 to 8 euro per kilometer of shore banks restored in Europe, but deeper studies would allow the players in the regions to better understand the impact of restoration. The list is non-exhaustive. I refer you to Brasier and Tal 2021 called Beaver Nature Ecosystem Engineers, which details clearly the gaps in knowledge we have when it comes to beaver restoration process. And I will now leave the floor to Margaux.
Voilà, donc pour ce webinaire sont présents avec nous
So,
deux
with the
chercheurs,
webinar, we have two
Annegret Larsen
researchers,
et Clément George.
Annegret Larsen
Donc,
and Chris
Annegret
Jordan.
Larsen
Annegret Larsen
est professeure
is
assistante au département
professor in
géospatial
at the University of
Lyon.
Wageningen in
Ses
landscape,
travaux
and
se concentrent
the
principalement sur
work
les
are
interactions
concentrated on the
hommes-paysages,
man-landscape interaction,
environnementales, mais aussi biotiques,
environmental retroactions,
et bien
ecosystemic
sûr la terre.
services, and
Avec cette recherche, elle
widening
cherche à
of the.
comprendre les processus
She
qui
tries to
sous-jacent
better understand
aux
processes
paysages
which
résilients
are,
que j'ai
found
afin
in
de mieux garantir
well-managed,
le
resilient
succès des
landscapes to
opérations de
ensure
régénération
success
et
of restoration
de régénération.
operations and regeneration
La
operations.
thématique entourant ce
The
cluster s'inscrit donc
theme
dans un
around
cercle
beavers
vertueux.
fits within
Et
this
puis,
scope of
elle
work,
s'intéresse
and
aux
her
impacts
works
dévastateurs et de la
deals with the
destruction
impact of
sur
beavers and of
sur
their
les rivières,
activity on
à
rivers, of
travers
course,
notamment les thématiques
especially
de la
the
géographie,
issue of
de la
hydrology,
taxonomie,
hydromorphology, and also
pour
on
faire très simple,
ecosystems
elle
and
abordera
hydrochemistry as well. And she will discuss the influence of beavers
l'écosystème.
on the structure and
Et
the
d'ailleurs,
operation of
ça aussi, notre
rivers.
deuxième intervenant est très
Second
expert
speaker, Chris
puisqu'il
Jordan from the
cherche
US,
au sein
who is a
de
researcher within
Northwest
the
Fisheries
Northwest
Science Center, donc
Western
le
Fisheries
laboratoire
Science
oceanique
Center,
de
the
l'observation
US agency for
océanique
the
atmosphérique,
Oceanic Atmospheric
au
Observation
sein de la
Agency
division biologie
within the
conservation.
Conservation Biology
Il est
Division.
aussi
He's
directeur
also
du
director
programme
of
de
the
recherche
Mathematic
Surveillance Système.
Biology program
Sa
and
recherche
system
s'intéresse
monitoring.
particulièrement
His
aux
research
interactions et aux
is focused
processus
on the
qui
understanding of
entourent
process will
les
form and
riverscapes
maintain
du
river
Pacifique, et
landscapes, so
principalement à
the
travers les
riverscapes,
données de la
through
biologie.
the
Donc,
especially
ça
through
touche à
biology.
un large
Chris worked on a
éventail
large scope of
d'activités de
biological
prospection sur
topics,
le
all
développement ou
focused on the
l'application de
development
méthodes
or the application
de
of
modélisation
methods
biologique.
to model analysis.
Parmi ces projets actuels,
Among the
on
current
retrouve
projects,
notamment le
there will
développement
be
de
the
simulations
development
type
of a
pour
simulation model of
intégrer
life cycles
des
to
connaissances sur les
integrate
processus
knowledge
physiques et
on the
biologiques
physical and
dans
biological
le cadre
processes
d'une aide à la
within the
décision.
framework of
Donc,
decision-making
le développement
support,
de méthodes
as well
de
as
restitution
development of
d'écosystèmes
river
spécifiques aux
restoration method
beavers
based
et la
on
réflexion justement
beavers
sur les
and the
processus
reflection
sous-jacents.
of the
Lors de sa
underlying
présentation,
processes.
il
In the
abordera les
procession,
services
Chris will
écosystémiques
discuss
du
the
cluster et
ecosystem
ensuite
services of
comment les
beavers
sociétés
and how
bénéficient
our
des rivières
societies
fluviaux
can take
locaux.
benefit from the riverscapes created by
Je vais
beavers.
donc laisser
With
la
no further ado,
place
I will
à
now leave
Annegret
the
Larsen
floor to
pour
Annegret
poursuivre sa
for
présentation.
the presentation. Thank you.
Super. Okay, so thank you very much for the kind invitation and the possibility to present my work, which is a few years ago, but I kept working on the topic. And also for the perfect setup in terms of who talks when, because I feel very honored that I talked before Chris, who's clearly more from the biological side. So it's a perfect setup. And also next week, I see, for example, that you also invited Christoph Angst to this to this event, and he's working very closely together with me on many of the projects that I show now. So thank you very much. I'm going to start, not bore you anymore. So I'm going to talk about the influence of beavers on the structure and functioning of river corridors. And I don't want to bore you too long with this. We all know biodiversity declines, right? But more importantly, in a European setting, we have a new conservation law coming up, the nature restoration law, which is now at the moment stuck within the European Union, but it's very likely that it is going to happen for all of us. And that will mean that by 2035, we will have to restore 25,000 kilometers of rivers, right? And it is also very clear from the setup of this law that this restoration is going to help or to be a lot based on nature-based solutions. So, and in the course of this presentation, I would like you to convince you that beavers are actually a nature-based solution and that we can use the beaver to help us restore those 25,000 kilometers of rivers. So just to give you a little bit of insight how I came to this topic and why it is so fascinating is because I'm actually a geoarchaeologist originally. So I look at the chronostratigraphy of sediments. And for a person like me, it is clear that we do not talk about natural streams. So when we look at our rivers, at least in what I am known to from Germany and Switzerland, then there is a thick layer of sediment on top of all those river floodplains, right, which is entirely anthropogenic. So we have researched that a lot in the past, right? These first 1.5, 2 meters, how those rivers have changed significantly since more than 1,000 years of indirect and direct human impacts. But what is less known, actually, and that was always what fascinated me, was that we know very, very little of what is below. Yeah, so this little gray layer that you see here at the bottom of the screen is what I would say is representing the more or less natural condition of this river, and we know very, very little about it. And in 2008, I stepped for the first time into a beaver meadow, and I looked at it and I thought, like, wow, that this could actually be what this gray river layer, what you see here at the bottom of this stratigraphy, could have created this. So, and that is when my personal beaver story started. Yeah. And it raises for me, it continues the question, how did those streams function in the past? What triggered that change? And more importantly, what do we base our restoration on? And when we, so it is very clear once you stand in a functioning and also in an older beaver meadow, right? It's maybe two decades old, like we have it in Germany, but maybe also in France, there are a few locations where you can see with your own eyes, right, that this is a very different ecosystem and it is very biodiverse and it buffers a lot of floods, a lot of changes. It stores much more carbon. It is much wetter than what you see here on the left, which is the same river upstream and downstream. Yeah, one with beaver, one without beaver. And all these feedbacks that we can see here is qualifying the beaver to be, from my perspective, a nature-based solution. So a nature-based solution is an ecosystem-based approach which helps us restore resilient rivers or also landscape and overall, and has a large role also in the biodiversity benefits, but also to create human well-being and an overall better future for everybody, right? It's also nature-based solution talks a lot about protecting people, optimizing infrastructure, and especially safeguard a stable and biodiverse future. So now the problem, and I call it a problem, it's not really a problem, but it is a fact, is that nature-based solutions are highly context dependent. And now I'm going to go further into detail now down in this talk, so because this is also what we find with the beaver, which makes it a nature-based solution, but also creates a problem if we want to use it for management. The beaver is an ecosystem engineer, and that has been explained before, so I would suggest skipping this. We all know by now from the introduction what an ecosystem engineer is, and however, from a geomorphic, from an Earth surface process dynamics perspective, is that we have not studied that very much in the past because there were not so many ecosystem engineers around in the past. So this is a little bit of a new topic for Earth surface processes as well. So what does the beaver do? Just a quick sum up. some of this has been said in the introduction already. If we do water accounting, how does the beaver change the water balance in a landscape? So it builds a dam, right? That's its main engineering capacity. It builds a dam, so it raises the water level upstream of the dam. Yeah, it increases residence time, but what it also creates, if possible, is flow diversions on top of the floodplain. It creates unchannelized and channelized surface flow on this floodplain. It increases, or it drains the shallow, the water drainage leads to an infiltration into the shallow alluvial aquifer, and it also raises the water table in next to the pond. So just to make that as clear as possible. So, and it has all sorts of other effects as well in the area of the pond, but I think I don't want to go into detail that too much. So it's clear that it increases the surface water storage, right? And also the groundwater storage increases around the beaver ponds. What needs to be also important to be understood is that a beaver very rarely only builds one dam as in a landscape. So it normally creates a sequence of dams, which we call a beaver reach in the course of this presentation. That's at least how I call it. So what the effect of this increase in water residence time is that the water gets, so people argue that the water gets purified, there's water purification, and the beaver changes the nutrient loads of the water, which is what that means. So especially with regards to our human modified environments, right, we may decrease the nitrate component within the water, right? But unfortunately, we also in time to time find that it's an ammonium increase within the surface water upstream. I always talk upstream and downstream of the dam or the Beaver River reach. Yeah. And it also, what is another coherent, more or less coherent trend, that it increases the dissolved organic carbon content within the water, which is because of dissolved organic carbon, yeah, which is because of the greater primary productivity within the beaver ponds normally. So I also don't want to go into detail here. It's all described amongst other papers, right, that we've taken all this information out from Larsen et al. 2021, which is a big review paper that we've written. So we summarize the finding in the literature up by making the point that I did before, which is about nature-based solutions. So it seems that the beaver impact is highly context dependent. So from a geomorphic perspective, looking at this graph, so it goes from from A to D, or so A1 to D1 is a gradient from upstream mountainous within a catchment to downstream very delta type environment in D1, and the upper part of that graph describes the situation without beavers, and the lower part describes the situation with beavers. And we can see conceptually on this graph is that the very high mountainous landscapes on the left have very little effect due to beaver damming, even though there are many dams over there as well possible. And also on the other side of the spectrum, on the deltaic, more flat locations, the beaver also causes less change. So where the beaver causes most of the change and hence can very likely create most of its impact is in the middle semi-confined valley systems in the middle catchment area. Yeah. So we then went on based on this conceptual understanding that we thought was correct in 2021, and we co-designed research questions with stakeholders in Switzerland. That was when I was still working in Switzerland, and policymakers over there. And we've identified three main questions that people and us were interested in. So one was, do beavers create a carbon sink or source? And for this, we tried to complete the budget, the carbon budget within one area, so also including atmospheric fluxes, but also DOC, DIC fluxes within the water. and organic carbon storage in the soils. And second, do the beavers actually create a water quality increase or decrease? Because from the literature, we found that it was not always so coherent, and in parts actually surprisingly coherent. So we wanted to investigate that. And then third, we were thinking that we wanted to model that on a landscape perspective, so that we get a more grasp on where the beaver could deliver specific ecosystem services within an entire landscape setting. So we did that for Switzerland. And and I wanted to put the water quality here at the front of this presentation because I think that is what many people here are interested in. So from the literature collection in 2021, we found that we had a very clear picture on deserved organic carbon, for example, so a clear increase upstream to downstream. We had a very clear decrease in nitrate, and suspended sediment was surprisingly variable, actually, I thought, while phosphate did not do anything. And what we were missing was some kind, from all the studies that we collected, we were missing the fact that that should all vary with seasonality, right, with the seasons. And we couldn't find any data or any background data on that. So we went out and we did our own study. So we were very lucky. We had a massive project going on in Switzerland where we could there were volunteers that sampled for us all the streams in Switzerland, right? And they sampled it for many things, amongst others, also nitrate. So, and we found that it is highly variable. So that was to be expected, but that it is so variable, the decrease from upstream to downstream that we expected, right? We didn't expect that. So you can see that overall, when we look at the entire data set, we found that nitrate decreases from upstream to downstream in the majority of cases, mostly in summer, yeah. But there is a whole lot of population in the data set, right, that is behaving totally different. So that's just a side. We tried. So this was a very big project. We had all sorts of factors. We had discharge, residence time, right? We plotted it against everything. And we found no real coherence, right? Or no real interpretation that it could explain that variability properly. And the only thing that we could find that is absolutely reliable is that it is the lateral connectivity between the river and the floodplain that leads to a decrease in nitrate from upstream to downstream in those Beaver river reaches, which lets the geomorphological heart beat faster, because this is what we always argued, we always thought would happen, and it is definitely correct and makes us argue for that we have to reconnect the river and the floodplain with each other in order to get those effects that we want from the Beaver, right? Which is a decrease in nitrogen load within the river reaches. And then just very briefly, with regards to the carbon budget, this is an extensive study at one side. We tied it up, we quantified all the carbon flux throughout the course of 1 year, and we found that the Beaver creates an efficient carbon sink. Yeah, so I leave it with this. This is going to be published soon, so you can look it up. And very important, so the thing that the take-home message here is that many people argue that we have methane emissions from beaver ponds, right? And that we wanted to check if this has a major impact on the carbon balance. And we found it's very negligible. So the carbon storage, due to the anaerobic condition and the decreased decay of organic matter in the sediments of the ponds, this is just so enormous that it creates a sink, and the methane emissions are, at least in Switzerland, in a temperate setting, very negligible. We found we did this. We quantified carbon content in comparison to before and after Beaver through a variety of places in Germany, older, younger, and also in Switzerland, and we compared it with each other, and we found that about 50%, depending on the precondition of the soils and which type of soil you have, we found an about 50% increase in carbon storage. So please note that 50% of nothing is nothing, okay? So if you have naturally a very low carbon storage within the soil because it's very sandy, for example, right, then you also get a very small increase, yeah? So, and then after that, we were trying to make all this, what we found out within Switzerland, to quantify these ecosystem services throughout Switzerland. And this was actually an absolute, and it was very new to me when we did this. We did this together with the Uni Manchester in that case. So Matthew Dennis is the cooperator here, and he did a wonderful job. And we managed to integrate these the results of the quantification of the ecosystem services into the VDC, which is a Swiss-wide planning platform. And now basically everybody who wants to construct something on a river or do a river restoration in Switzerland has to look at our map before doing something, which is a very big success. And I hope it's going to improve the management of those beaver streams. Hopefully it makes it better. But as Christoph Angst is speaking next week, I hope he's going to also give you some information on that. And this is again on the model. So we also quantified this service, for example, not just ecosystem service. And we found that there's also, by analyzing the data that we did, quantify the positive and the negative impact of beavers throughout Switzerland. And we found that there's a sweet spot around 700 meters in elevation where it would be fantastic to expand beaver population, because there we have a positive effect while very little negative effects. That was the goal of the study. So we can actually give a concrete suggestion to the government where they should potentially, be a little bit more generous with the negative effects, because it has a lot of positive effects in these areas, in this elevation area here. So overall, to wrap it up, I think that beavers, I hope I convinced you that beavers are a nature-based solution if you needed convincing. And but it is very important to keep in mind when you do research or you propose to work with beavers as a nature-based solution, that their impact is highly context dependent, much more than you think. Yeah, but we can quantify this context, and I hope I showed that to you as well. And and I want to basically close with that Science for Policy, which we did together with the Swiss in 2022 as a total win-win. And I think we created evidence-based change, which was one of the goals that we had for this project. So overall, I want to close here, and I want to make sure that this was all a lot of teamwork in the past years. So many people helped. It's by far not me who did most of that work. But I'm happy to present it here, and I want to thank you also for your attention.
Merci beaucoup, Annegret.
Thank you, Annegret. First, clarify that questions will be grouped at the end of the two presentations. I will give the floor now to Chris.
Is that displayed correctly? Excellent. Okay. Thank you so much for inviting me here to talk to you about something that is near and dear to my heart, and that is beaver riverscapes, and riverscapes as socio-ecological systems. The ecology exists along with people, and that is not. There is no better example of that than working on beaver in riverscapes. And I want to talk about some of the ecosystem services. That is a human perspective of riverscapes, what we get from the natural world. That is how our human societies benefit from beaver riverscapes. But how do we do that in concert with beaver, so that there is the mutual existence of both our societies and beaver societies? So beaver are very industrious. They We know them for their work ethic, as it were. Busy beaver is how we've captured that in our language, at least in English. They eat, and they eat vegetation. And they build houses. And they build dams. They modify the landscape for themselves. And this is the beaver engineering, the beaver ecosystem engineer that you've heard from the first speakers. And it's very obvious what beaver do to the landscape, to the riverscape. So what are the beaver ecosystem services? Well, how do beaver benefit us humans? Well, there are many, many, many ways, far too many, and there are wonderful summaries of those in books, in a couple of review articles that have already been referred to by the first speakers. I just want to pick a couple of them to talk about them, and then how those might be in conflict for people. But let's remember that we humans don't receive benefits directly from beaver. Humans benefit from beaver being beaver. Humans benefit from beaver riverscapes, how beaver modify the valleys, streams, and rivers to make a beaver living. And beaver riverscapes need three things. They need space, they need water, and they need food. And human riverscapes need three things. They need space and water and food. And so you can see immediately there's a potential for conflict, because we are looking for the same things out of riverscapes that beaver are. So I want to look at two examples to demonstrate this, how beaver riverscapes are perceived as beneficial for human riverscapes, and two ways that we can mediate conflict. And they're just representative of the many ways that we can mediate conflict, so there can be this mutual occupancy of riverscapes. So ecosystem service number one, overall riverscape productivity. And that can be a target for biodiversity, target species for restoration. That can be for water quality, water quantity, all the things that we've heard from Annegret just now. But how does that happen? So conceptually, here's just a cartoon of a stream, a cross section through a riverscape. So from left to right in the valley, looking down, the water is going away from you in the channel. There's water in the shallow groundwater, and there's deep groundwater that's separated from that channel. And if it rains, there's water in the surface with the vegetation. But there's potentially larger, drier areas, and that's going to change vegetation, types of vegetation, or the productivity of that vegetation. In a stream with beaver, and you saw some wonderful cartoons of that with Annegret's presentation, there's more water. The ability to store water within that floodplain, not just in the lens that is below a channel, and not just in the surface from rain or snow, or from the deep groundwater, but throughout the volume of that riverscape, throughout the volume of the floodplain. What does that look like on the landscape? On a natural beaverscape, beaver riverscape, there's water everywhere. And so it's clear that beaver are modifying where water goes, and that there's more water stored, there's more water held in riverscapes that are dominated by beaver and their beaver behavior. Well, what does that look like in seasonal or year-to-year drought? That is, with missing the water coming in from the surface, the precipitation. So you'll have surface drying and changing the vegetation. Vegetation might go dormant, or there may be a change in the species composition outside of the influence of the channel. That is mediated by beaver occupancy of the riverscapes, because there's more water laterally. So that is going to change the timing of access to water and the spatial spread of that water. And what does that look like on the landscape? Here is pasture land. This is cow pasture. When it's seasonally dry in California, where most of the precipitation comes in the winter, a Mediterranean climate, where the rain and snow happens in a few months of the year. And you can see in an un-beaver modified part of this riverscape, it's very narrow. And in a beaver modified part of the riverscape, it's very wide. And you can see that just from the color, just from the vegetation. And this is where the water is. It's not just where the standing water is, it's where the water is accessible to the plants. And so beaver are changing the distribution in time and space of water. So they're changing the basic potential for a riverscape to be biologically productive by changing the distribution of the water. They also change how the physics of flowing water interacts with the biology and interacts with the landscape. So in a cartoon of a river without beaver, it's a simplified single channel. And in areas where there are beaver, it's elaborated. The water is allowed to spread laterally because of the dams and also because of beaver canals. One of the most underappreciated feature of beaver behavior is their canal digging. So that's directly moving water laterally. What happens during a high flow, either a seasonal or a rain storm, a rain event? What happens when the physics of that flowing water changes? So a large flood pulse or a large high water event makes this part, the simplified channel, physics dominated. The gravity, the flowing water, and the friction, the ability of water to pick up and carry things, dominates what happens in the single channel. That the physics of that moving water are in a sense mediated, balanced, resisted by a beaver dominated riverscape because of the space. So that energy is spread out. The energy of the flowing water is dissipated by encountering things in the water, and those things in the water are biology. And so what is happening in a beaver dominated riverscape is the physics of flowing water, the energy and the work potential of flowing water is resisted by biology, by structure that's in the channel, and as well as the space where the biology forces that water, that moving water, that energy to spread out. And what does that look like? So here is that same pasture land when beaver came in and the water was allowed to spread out. At first, it was dry vegetation that was now accessible to water moving laterally. And so at first with a seasonal flood pulse, so this is when the snow melted in the mountains and the water came down onto the valley floor, the water spread out, and it was an area that had not seen that water for 100 years. And it looks ugly, it looks messy, and there's geomorphic work happening. There's sediment being moved around because there's not a lot of resistance. There's resistance from space. The water is spread into a thinner layer. It's not concentrated into a single flow path of a ditch, but it's spread out. But there isn't the biological resistance. 1 year later, the biology responds to the availability of water. And now you have biological work that's enabled by the presence of water, presence of the fine sediment that's come onto that surface. And you have this continual cycle year after year of geomorphic work being resisted by biological work. And main feature of beaver adding work to riverscapes, to beaver floodplains, is enabling that biological work, either building the dams themselves or modifying vegetation so that it has more stems, it's more productive because they're chewing on it, and digging canals and spreading the water out. So biology resisting the physics of flowing water makes beaver riverscapes more engaged and more productive, at least from the biology side or from the vegetation side, clearly. We wanted to understand that from protected species management, from salmon and trout. And in North America, and mostly in the northwest part of on the Pacific coast, streams that would have naturally supported salmon populations are the target for enormous effort, an industrial scale effort of restoration. And that industrial scale tends to be industrial-like actions. Engineers saying this is what a river needs and building playgrounds for fish. And it doesn't work because what we need are nature-based solutions. What we need is the natural environment to be returned to the conditions it was when the salmon populations were thriving. So how do we do that? If we don't understand how these systems work, what is our target for our restoration? seeing how beaver engaged floodplains, beaver engaged riverscapes are more biologically vibrant from a vegetation perspective, made us think, would that also hold for a fish perspective? And so we did a very large experiment, was to take, and this is in agricultural land, here is a single threaded channel, so a simplified channel, more like a ditch than a river, and added the complexity of beaver, or mimicking beaver dams at first. And we did that. And so here is the same image at the same time of year, about 10 years later, after the complexity, the biology had been increased within that riverscape. So the biological component could now resist the physics of moving water. And there was enormous elaboration in the inundated area where you could see water. There were many more flow paths or side channels, little channels, so 1,000% more of side channels. And there were more fish. So why? What did we change by doing this? But that's not us, it was the beaver that did this. So if we look at this, we had monitoring wells and the examples that Annegret just talked about, water outside of the channels, that groundwater adjacent to the channels, up to several hundred meters away from the channel, in the areas that were modified by beaver, so treated. And the treatment in this experiment was adding beaver. So beaver came in on their own, we didn't release them, and built dams. And as a result, there was a 25 or 30 centimeter increase across the entire floodplain of the groundwater. So that's lifting up the water everywhere, increasing the volume of water available to plants and stored to be released later in the year. So it's affecting the timing and the distribution of water. Because of that complexity in the channel, it changed how the water moved from the surface into the groundwater and back. And you can see that most readily with temperature, the temperature of the water. So here's a very simplified part of the channel, and each red dot is where a temperature measurement, a temperature logger was placed in the water. And through 3 days in the summer, the temperature of that water changed from night to day, but the temperature difference between these different locations in the stream was very, very small. So everything was in any one part of this reach, the water was doing the same thing. It was staying in the channel, it was heating up in the day, and it was cooling down at night, and that's just the effect of the sun. In a different reach where beaver modification had happened, where there are beaver dams, so here's a dam, here's a dam, here's an abandoned dam, we measured the water temperature, and we found a very different thing. We found that in some places, the daily pattern existed, and the water was doing the same thing. And so it was acting like this simple ditch here. But in other places, the water temperature was much, much cooler, almost 15 degrees Celsius cooler, and it didn't have a daily fluctuation. And this is water that's coming out of the shallow groundwater. This is water that's been cooled by being in contact with the substrate underground. And then everything in between was possible, all combinations. And this means that the hydraulic complexity, piling up water behind beaver dams, was the source of pressure locally to push water down into that shallow groundwater and displace water that had been cooled back up into the channel. So two things happened. There was a net cooling of the water, and there was enormous variability. There was diversity of conditions. And this is what fish thrive on. If they want to be warm, they need a place to be warm. If they want to be cool, they need a place to be cool. And they do this on a daily basis to digest and to rest and to feed. They need the different temperatures of the environment. That doesn't exist in a simplified system. It does exist in a beaver complexified system. So now we have two elements of why biological productivity might be better in a beaver riverscape: water timing and availability, variability of micro parts of the habitat from a temperature perspective. And when we measured the fish, were there more? Are they growing better? Are they surviving better? The answer is yes. And so this is a very complicated figure. I'll give you the quick message. there were about 70% more juvenile fish, 1-year-old salmon, in this stream, in the places that were modified by beaver. They survived on a 3-4 month basis. When we tagged individual fish and came back and saw if they were still there, their survival increased by 50%. So they were doing better as individuals. Not just more of them, but individuals were doing better. And if we weighed all of those fish that we caught, there were more grams of fish per square meter per day. So the biological productivity of the entire area was increased. This work has been repeated, not with the complexity of tagging fish, but just asking simply the number of fish question in other places. Here's another example where a very simple system that didn't have beaver were encouraged, they were released, and dams were built, and beaver built up their own riverscape. And we counted the number of trout before beaver were present in that reach and after. And in places where beaver were modifying that reach, there were many, many more, 100-fold more numbers of fish. And so these are more complicated biological places. And the reason is that habitat complexity, but even down at the scale of single-celled organisms, that complexity was happening. And this is another complicated cartoon of, in a very simple system, the water is moving through the ditch quickly. And if there is the nutrient cycling that's happening that Annegret talked about, it's happening quickly as the water moves down. And so the cycle, it's like a spring that's been stretched out. When there's more complexity in that stream, it's like the spring has been compressed and it's slowed down. And so there's more time for that processing to happen. So more cycles can happen. Also, because that water is being pushed underground, that processing happens in a film around every one of the pieces, every pebble in the stream is where that processing happens. And because water is pushed down and back up to the surface, there's more volume of connectivity. There's more volume of ability for that processing to happen. And you can see that if you measure the isotopes of carbon and nitrogen, that is how much trophic enrichment is there, from areas that are just control reaches to areas that have been restored. And in general, there's an upward and a right to the right shift of all of those different kinds of organisms, what isotopes of carbon and nitrogen they are built out of, which means there's more biological productivity happening in areas that have been complexified like this. So there's more place for the food chain to happen, and the food chain is richer, has more levels. And that supports this overall observation that these are biological hotspots. So let's talk about hotspots. Let's talk about fire. Water is energetically unfavorable to burn, as Emily Fairfax says. And so there's more water in a beaver riverscape, but does that actually change its ability to resist wildfire? And with climate change, we are seeing across North America, across Europe, the increasing prevalence of large fires, because we have modified the landscape and we've modified riverscapes. So we've changed fire behavior. Can beaver impact that fire behavior? As removing beaver and beaver riverscapes from the surface of the Northern Hemisphere, has that allowed and contributed to the change in fire behavior? And I think that the answer is yes, and we can see that. So here's our back to our cartoon, or to Emily's cartoon, of how a floodplain works with and without beaver. Now, if we add fire, the drier parts of that floodplain that's fuel for the fire. And are the wetter parts of that floodplain not fuel? So that's the question. The answer is yes. So here's a large fire a few years ago in the state of Idaho in the northwest of the US. And there are patches of green throughout that burnt landscape. And those are associated with beaver colonies. Is this one lucky example that Joe Wheaton saw this picture and put it on Instagram? Or is this a general phenomenon? And the answer is a general phenomenon. There are a number of pieces of research that have shown that this holds true looking across sizes of fire and across space and across time. And I'll just show you some examples without showing you a lot of the data. So again, and this is mostly work done by Emily Fairfax and her colleagues across the Western U.S. Where there's beaver activity, there's a beaver dam, there's water stored, and it resists fire. And it resists fire on an enormous scale. Here's a very large fire that happened in 2020 in Oregon, and the darkest parts are a very hot fire, so it has killed the trees. The brown part was just a crown fire. It burned the vegetation, but it didn't necessarily kill the tree. And the green is where the fire wasn't of a sufficient, the temperature didn't get to the point where it affected the vegetation. And this is immediately after the fire. And this happens on an enormous scale. This was a very big fire, and it had very hot patches and less hot patches, and it had very cool patches where there was water. And where there was water and where that water was elaborated, laterally spread out, was where there were beaver dams, and all the beaver canals spreading the water throughout the landscape. And this acts as a refuge, a place where animals and plants are in a sense surviving the fire. It also acts as changing fire behavior in terms of the spread of fire. And the potential for it to affect fire on a landscape scale depends simply on the amount of beaver riverscape that's intact across the landscape. So again, it's a question that we would have as society of how much fire resilience could we get from beaver is how much riverscape could we give over to beaver. But it isn't all good, right? Beaver want to occupy that floodplain, occupy floodplains and riverscapes that we've occupied, that we've put our infrastructure on. So water on the roadway because of a beaver dam. This cherry tree is no longer a cherry tree because of beaver, because it's food for beaver or it's food for us. So how do we resolve these conflicts if we want both human societies and beaver be in the same places? Well, we have to outthink the rodent. And it's not that hard. And we have to make choices. We have to make compromises. Simple devices can be used to regulate the height, the crest elevation of a beaver dam. And it's really just building a leak in a beaver dam. It's very inelegant. It's very simple technology. Here's a beaver dam. The water is flowing here in this direction. It's piled up behind the dam. And there's a pipe that goes from an inlet cage. And the cage is protecting the pipe from beaver plugging the pipe. And it takes some water through the dam and sets the elevation that rather than the dam itself setting the height of the pond, it's set by the pipe. Again, not an elegant solution, but a functional solution. So you make a leak in the dam that the beaver can't solve, they can't fix. And you can then collaborate, leave a beaver pond, but a beaver pond at an elevation that's convenient to you. It's not a permanent solution, it's a good long-term solution, but it allows the coexistence. The other conflict comes from food. Us growing food and beaver viewing things that we grow for food as food for themselves. So here's a vineyard in the northern part of the Willamette Valley in Oregon that's near a stream, and the beaver have found the vineyard, and they are eating the vines. And the vineyard manager is not happy about that and wanted a coexistence solution. And an electric fence works perfectly well to keep beaver out of the vineyard. But it's an electric fence that you would never have built before, because it must be an electric fence at a beaver height. So the first two strands of the electric fence are within 20 centimeters of the ground. This is not an electric fence that would keep cows or sheep out of this vineyard, but they keep beaver out of the vineyard. And you can see this first row was where the beaver had found the vineyard. Similarly, you can fence. So here's a very old apple tree that the vineyard owners wanted to protect. And so here's fencing far enough away from the tree to keep beaver out. And I'm going to end with this, a picture of coexistence, where both humans and beaver are living in this riverscape, and they are both benefiting from the space, the water, and the food, but they figured out in this one example, in this place, how to resolve the potential conflicts so that both species can be living there and benefiting from beaver behavior. Thank you.
Merci beaucoup pour ces présentations. Merci
Thank you
beaucoup.
very much for the presentation.
Avant de passer
Before
aux questions
moving on to
du
the
chat,
questions
on va
on the
commencer
chat,
peut-être par des
we'll
questions
start maybe with questions
pour Margot, Clément
from Margaux, Clément,
et également Arnaud.
and
Si vous
Arnaud
avez des
to the two
questions,
speakers. Do you have any specific
c'est
questions
c'est
to the two speakers?
Alors, oui, moi j'aurais.
Yes, I do have
Pardon,
a. Sorry.
je me détends.
Okay.
J'aurais
Yeah, I
une
do have
question un
a
peu
question to
pour Chris au
Chris
sujet des poissons
concerning fish,
et plus notamment les
and
salmonidés
especially
qui ont été étudiés.
salmons have been studied
Est-ce
a
qu'il y a
lot.
des études qui ont été menées sur d'autres
Were study carried out on
espèces
other
de
fish
pêche ou
species,
peut-être
which could be maybe less mobile within a river?
Most work has been done on trout and salmon, yes. But there are observations that beaver pond habitat, beaver modified floodplains are exceptionally good habitat for lamprey. And mainly because the early life stages of lamprey, so lamprey are an ancient jawless fish that live in both Atlantic and Pacific in the northern hemisphere, and they spend a decade almost in fresh water before going to the ocean to reproduce or to grow larger and then come back to fresh water to reproduce. And they live buried in the fine sediment. They are filter feeders in fine sediment. And when we have simplified streams and turned them into ditches, turned them into transport areas to move water and move things in water, we remove lamprey habitat. And by bringing beaver and beaver modified floodplains back, we are making lamprey habitat. And so that is one species that is enormously benefited, less studied, an important cultural species for the indigenous people of North America, and one that will benefit from elaboration of floodplains. And then there are some suckers, so catastomids, that are also benefit from beaver modified floodplains, but some of the other fish, minnows, sculpins, are less well studied, but are seen in higher densities, and so it is assumed that they are equally benefiting. But the quantification of the numbers and change in survival and possibly changes in species compositions is you are absolutely right, Arnaud, is nowhere near as much work has been done as it has on salmonids.
Merci beaucoup.
Thank you.
Oui, donc moi j'aurais une
I
question
do have a question
pour les deux intervenants.
for the two speakers.
On a pas mal parlé d'analogues,
We talked about beaver dam analogs. Now, when it comes to, take the French example, rivers which have been incised or scarred because of the rural changes, there are indirect anthropic impact. Now, those beaver dam analog construction, is it durable in time, or with time the river will expand and maybe river will go back to its simplified degraded form that it had at the origin, and therefore could there be that would need regular intervention for maintenance, for example? Would there be necessity for maintenance? Question was to the two speakers.
Yeah, so Chris, I don't know, I think you have more experience with beaver dam analogs over there, right, in the Mediterranean type climate. I think what I observe from when beaver dams breach as well in incised channels, that is what you refer to, right? Then the channel goes back always back to the original location. That's very interesting. It incises back into it, right? But then it leaves the floodplain, the small floodplain in incised channels of an inside floodplain type of system. And then it leaves that with a lot of sediments and a lot of carbon-rich sediment as well. So that's what I observed from real beaver dams. But maybe, Chris, you want to comment more on the analog perspective, I think.
Yeah, I agree, Annegret, and that's an excellent question, Clément. When we try to restore a simplified river system, so simplified by being a single channel, a higher energy or transport channel because it's incised, we have two problems to solve. First, is the channel actually incised? That is, has it cut down through its original alluvial surfaces? Or is it, as the examples that Annegret showed and that we've seen throughout North America as well, is there excess sediment? There's more sediment has been deposited across the floodplain, and it's not actually incision. The stream is at its original base control, and the rest of the floodplain has been brought up anthropogenically. And if that's the case, it's inappropriate to try to put the river up on top of that surface. And the only way you can fix that is to scrape off all of that sediment and bring the surface of the floodplain back down to where it was along the entire course of the river, from the headwaters to the bottom. And that has been done very successfully in a few places. So if first in diagnosing the incision problem, you find the river hasn't cut down, but the floodplain has come up, you have to fix the floodplain going up. Now, if the river has cut down and simplified, it's now too high energy. It made the floodplain because it was a deposition environment. It was a low energy environment that dropped off things and built the alluvial floodplain. And it has become simplified and channelized and is now transporting stuff away. And so you need to dissipate the energy. And if you choose to dissipate the energy by putting hydraulic roughness or beaver dam analog or a piece of wood or a boulder in that channel, you dissipate the energy only as much as that piece of roughness is still there and as if the channel is still hitting it. So if the channel migrates away from it, it's no longer dissipating energy. And so it's not so much maintenance as your treatment, your intervention was very local in space and in time. And you might have to come back multiple times to keep chasing the channel until you dissipate the energy at the scale of the entire riverscape. You can do that in one pass with what's now called stage 0 restoration from Colin Thorne and Brian Kluwer's 2014 channel evolution model paper, where they said the stage 0 is the original condition before occupancy of the floodplains by industrial humans and sort of industrial society. And if you want to get back to that place where across the entire riverscape, the physics of the river and the biology are in balance, you can do it in one pass, and that is returning the elevations and the amount of roughness across the entire riverscape. If you don't have permission, the space, or the money to do that, and you want to do the small interventions, you have to keep chasing it. And I say it's a conversation. You're going to have a conversation with the river. You're going to talk. You're going to ask it to do something here. It's going to tell you it doesn't want to. You're going to try again. And that might take a decade. That might take 10 years to slowly convince the system to behave in a different way. And so absolutely, if you are going to use, and that's the whole idea of the low-tech and process-based restoration, is the interventions themselves individually are low risk, possibly low cost, low effort, but it also means that they are low impact. And so one set is not going to be enough. You are going to have to keep coming back until nature takes over. Excellent question.
Okay, now we will take questions from the chat. So first question from Emma. This nature-based solution works where there is enough space so that the riverbed could spread. But the main problem we face in France is that space is occupied strongly by human activities, and therefore we cannot always build dams. Caster dams are only allowed in zones where they will not disturb economic activities. How can we use this restoration solution in such a context where space is minimal or constrained?
Was there a dedicated person for this question?
Yeah, go.
Yeah, shall I? Because we've just struggled with this, right? Because we did the research in Switzerland, yeah, so where also the agriculture lobby is very, very strong, and many people live along those rivers. And on top of this, the Swiss have in the 50s apparently built roads always directly next to all rivers. So basically on the levees, yeah, there are roads, and if there's infrastructure, then there's definitely no beaver, you know, so it's a very difficult setting to have beavers dam the country, right? So so what we did in this ecosystem service model that we made is that we basically did it's like a GIS model, right? So we had all the data available, we cut it all out, you know, we identified areas where it would be very beneficial to have beavers, and then we removed all the areas that could be of any problems regarding agriculture, and then removed all the areas that could cause some damming of the roads. And we created scenarios. So we have a strict scenario where we deleted everything that could have any impact, and then only pasture basically and forest was then classified to be of little conflict. And then we created very strict scenarios where all the infrastructure has to be intact and stuff like this. So we played around, and we created 3 scenarios of high, middle, and low impact. And the way forward, I think, from there is that you basically first start with the low impact. So the green areas, how we classified it, very simplistic. So the green areas, you let the beaver, you know, be happy there, and then you go into the yellow and potentially let some red places as well, if possible, be impacted. So that was, I think, that was the approach that we took. But it was quite a bit of work. So, but it works. I think it was possible.
I would like to offer another perspective, that when we ask the economic question, we often don't use the right time scale. And so, for example, the coexistence structures, so protecting culverts, so stream road crossings, or building the pond flow level devices, they cost money. And not a lot, but they do cost. The alternative solution is lethal trapping, removing the animals, killing the animals that are causing the problem. But if there is a place that's attractive to a beaver, another beaver will come there. And so on a short term, maybe 1 year economic analysis, it's cheaper to trap and kill the animal. But on a 20-year scale, or across an entire administrative area, canton or a state, at that scale, it is cheaper to do the coexistence structures. You have to think at a different scale. And those analyses have been done by state departments of transportation in the US, that either trapping, continually trapping, or one-time building and maybe some maintenance, some coexistence structure. There is an amortization, there is a cost return timeline. Also, I think when we talk about infrastructure within the floodplain and the potential for it to be damaged by floods, we talk about the large investment in flood control projects, in dams. And we say they have saved billions of dollars in potential flood damage over 50 years. But what are the losses? What is the biological productivity that has been lost in that same 50 years across the entire watershed that is now modified by having a large dam in it? And we never ask that economic question. We only think of the human benefit from the danger of moving water, but not the human benefit from the presence of wet, flood-connected floodplains. And so I think when we ask that economic question, if we want to do that comparison, if we're going to use money as the currency for decision making around nature-based solutions, I think the economic analysis must be a fair one, to ask those questions on the right time scale and the right space scale. And many of these nature-based solutions do end up being economically beneficial to do them. In areas where water is limiting, like in the Western US, there's a lot of money that's spent to move water around and to pump water. That water naturally would be across the floodplain and seasonally available for growing grass or growing cows. And that's a different way of doing business. So it's a cultural change, but it is still equally economically viable. Ranching is still possible in a beaver modified world. It's just different. It's different than the way we've done it for the last 100 years. And so we need to both restore streams and we need to support agricultural communities to change practices, change the type of cow, change the type of forage that's grown, change the movement of herds to allow the utilization of a floodplain engaged system. So I think it is possible, but it means asking some questions we don't usually ask.
Question for Céline Blair, for Chris. The pipes through the leveler pipes dams to level them, does it have an impact on the fauna and on the fauna? And if there is an impact, how can we minimize such impact when you use those pipes to lower the level?
Yeah, there's potentially an impact because the impounded area will be smaller. So you're taking some habitat away. In terms of moving aquatic species that move up and down the river, there should be no impact because at high flows, when there's a lot of water, water still goes up and over the dams. It doesn't all go through the pipe. So the pipe is meant to be a leak. It's not meant to contain the entire river. If the pipe contained the entire creek or river, then yes, there could be biological impacts for aquatic species that wanted to move up and downstream. But most times those species are moving when there's higher water. So some larger fish like salmon move up and over beaver dams easily, but they do so at high flows. And so having a small leak in the dam doesn't affect that. So yes, there are impacts, but the impacts themselves are relatively small, and the impacts are acceptable. We've made that calculation because the alternative is removing the beaver and removing the dam entirely. And so again, it's a compromise. So there's reduced ecosystem function, but it is larger. The function is larger than it would have been if the beaver and beaver dams were removed.
Très bien. Eh bien, je pense qu'on a le temps pour une dernière question.
We got time for one last question. If you have other questions, please do get in touch with the speakers directly. So last question will be from Baptiste Cadet. The question is, why is the restoration of the ecological continuity by destruction of farming soil of mills is negative for the river, whereas the fragmentation from beaver analog dams is considered as beneficial?
Oh, that's a very good question. That's a very water framework directive question. Yeah, because we destroy all the mill dams, yeah, along to recreate the longitudinal connectivity, right? But then we get beavers to basically do the same thing, just differently, right? That is probably the question, right? As far as I understood. Very good, because I also when I started this, I also had the same question. But a beaver dam is not a mill dam, huh? So it's transmissible. It continuously changes, so it's never the same. Yeah, and that, from my perspective, at least, this constant change is what creates a change in habitat, creates a change in biodiversity. It's just dynamic, right? While a mill weir is not at all like this. It's also, when you look at it, it already looks different. It's not as biodiverse. I think it's a continuous change and the increase in dynamics that makes all the difference. But maybe Chris, because you also remove those mill dams in the US, right?
Yeah, I think yes, the dams are different. They're leaky. And as Annegret said, they change, they move. But there are also two other very important things that beaver do other than build dams, and that weirs and mill dams don't do. And that is build canals and chew on vegetation. Beaver modify the type of vegetation, the amount of vegetation. They make vegetation more productive around streams by chewing on it. Those plants are adapted, millions of years of coevolution, to be chewed on. And they are more productive when they're chewed on. And the species composition is more rich, and the biodiversity responds to that species composition. And so dams are a thing that we focus on and that we mimic. And there's some thought that we humans have learned from beaver to make dams. But canals are just as important, if not more important, for lateral connectivity and modifying the vegetation. And so if we humans did both of those things, we could replace the function of beaver. But we tend to just focus on holding up the water and still keeping the rest of the area simplified around the water pile behind a mill dam or weir or an irrigation diversion structure.
Thank you. Thank you very much. Thank you to Chris and Annegret. Do not hesitate to contact them by email if you've got questions. For the questions we have time to answer. I'm sure there will be plenty of questions. I'm sure they'll be happy to answer your questions. Congratulations to the students, Margaux, Arnaud, and Clément, who did the proper facilitation of this seminar. Thank you for the presentation of the question. And thank you to the translator, that's me, thank you. And so see you on Monday for the continuation, Monday at 2. And Antoine, I'll let you conclude. Yes, there will be a sequence of events. I'd like to mention that at the national level, there are events organized on the topic of beavers. It's called Year of the Beaver. You will see the series of events which exist. And finally, I would take advantage to say that at the end of the year, the French Office of Biodiversity and other players will do a seminar on beavers. So this is a set of joint actions. And thank you, and see you soon for the next event on Monday.